In this video, you are going to learn about the LRC series circuit, impedance, and phase angle. First, let us discuss the LRC series circuit, in which it is a series circuit that consists a resistor, an inductor, a capacitor, and an AC or alternating current source. This circuit also includes a single path for current to flow, while the voltages of each component vary. LRC series circuits have various applications, including the tuning of circuits in radios and oscillators. And we have here the diagram for LRC series circuit, in which it has a AC source, a resistor, an inductor, and a capacitor. And the current in this circuit is flowing from A to D. Next, we are going to discuss the phasors relationships. First, the resistor, where the voltage and current are in phase. So the corresponding phasors always points in the same direction, meaning wala sila'y kalahian. And the value of the VR is equals IR, where the VR there, it is the voltage across the resistor. And the I, it is the current flowing through the circuit. And the R, it is the resistance of the resistor. Next, an inductor. The voltage leads the current by 90 degrees. So the voltage phasor points 90 degrees counterclockwise from the current phasor. Its voltage amplitude is VL is equals IXL, where the VL there, it is the voltage across the inductor, and the I, it is the current, and the XL, it is the inductive reactance, calculated as XL is equals to pi FL, or XL is equals WL, where the W is the angular frequency, and the F is the frequency of the AC source, and L is the inductance of the inductor. And the last one is the capacitor. The voltage lags the current by 90 degrees. So the voltage phasor points 90 degrees clockwise from the current phasor. Its voltage amplitude is VC is equals IXC, where the VC there, it is the voltage capacitor, and the I is the current, and XC is the capacitive reactance, and can be calculated as XC is equals 1 over 2 pi FC, or XC is equals 1 over WC. And the C there, it is the capacitance of the capacitor. So now let's move forward to the next topic, which is the impedance. Impedance is the one that opposes the flow of the current in the circuit. It is a combination of resistance and reactance, and measured by ohms and represented by a symbol Z. And here's the formula for impedance. Z is equals the square root of R squared plus open parenthesis XL minus XC close parenthesis squared, where the Z there, it is the impedance, and the R is the resistance of the resistor, and the XL is the inductive reactance. The XC is the capacitive reactance. And the XL minus XC represents the net reactance in the circuit. So, before ta mag-derive sa formula, ato sa siyang i-identify kung asa gid ay siya gikan. So, diri gid gasugod ang impedance formula sa voltage amplitude where the V is equals the square root of VR plus VL minus VC squared. And the first step we are going to do is to substitute the value in terms of current, where it is the square root of IR squared since si VR is equals to IR and plus IXL since VL is equals to IXL and IXC since the value of VC is equals IXC. Then copy the squared. And next is factoring out the current and it will result to I square root of R squared plus XL since na-cancel naman si I minus XC squared. So, we define that the impedance Z is the ratio of voltage to the current I. So, Z is equals voltage over current. The same with the value of R is equals V over I in DC circuit. Now, let's substitute the expression for V into the impedance formula where Z is equals I square root of R squared plus XL minus XC squared over I. And next we are going to cancel the current. And it will result to Z is equals the square root of R squared plus XL minus XC squared. So, this is our final formula for the impedance. So now, let's derive the formula of impedance if we get the resistance. Let's copy the formula first. So, ang first nga atong buhaton is atong i-square both sides. Since na-square naman ta both side, ang atong next button is cancel. Then, i-copy ra na to which is Z squared is equals R squared plus XL minus XC squared. Since, i-cancel naman nato ang square root so wala na siya square root. And ang sunod na to buhaton is i-transfer nato sa other side si XL minus XC. Since si R squared man atong gipangita. So, inani na din siya where Z squared minus XL minus XC squared is equals R squared. So, naabot na din ta ani nga formula where R squared is equals Z squared minus XL minus XC squared. Unya, kay napa man siya R squared, so dili pa na mao tong final formula. So, ang atong buhaton is i-square nato both side. Kay diba kung usay mo buhaton sa pikas nga side, dapat buhaton po nimo sa pikas side. So, makancel na nato si squared. And mo na din atong final formula where R is equals the square root of Z squared minus XL minus XC squared. So, muna na ito ang final formula for the resistance. So, another derivation if ang ato na pong pangitaon is si inductive reactance and si capacitive reactance. And ang atong unang buhaton is parehara kaganiha where squared na to both sides para makancel ang square root. So, mawala na dayon ang square root. So, z squared is equals r squared plus xl minus xc squared. So, after that, ato na po siyang i-transfer. So, z squared minus r squared is equals xl minus xc squared. Na minus siya kay ato man siyang i-transfer. After that, since si xl man og si xc atong gipangita, ato siyang i-square both sides para makancel ang squared. Same sa atong gibuhat kaganina. So, xl minus xc is equals square root of z squared minus r squared. If ang atong pangitaon is the inductive reactance, so xl is equals xc, the positive or negative sign, square root of z squared minus r squared. Positive or negative sign siya kay mag-base siya sa given nga direction. And if si capacitive reactance na po datong pangitaon, so capacitive reactance is equals negative xl, positive or negative na sign, square root of z squared minus r squared. And also, it is equal to xc is equals xl, positive or negative na sign, the square root of z squared minus r squared. Guys, take note that xl is equals to wl and the xc is equals to 1 over wc and the w is equals to 2 pi f, where the f is the frequency.
Okay, now, let us proceed to phase angle in LRC series circuit. So, phase angle is the position of a point in time on a waveform cycle. It is commonly used in the context of oscillation, waves, and alternating current or your AC circuit. So, phase angle is measure of the position of a wave within a cycle. In simple terms, it shows how far the wave has progressed from the beginning of the cycle. So when we say wave cycle, it is a complete rotation of the wave from the start of 0 degrees to the end of 360 degrees. So the phase angle is measured in degrees or radians. Remember that class, that phase angle is measured in degrees or radians. So, phase angle is the angular displacement of two oscillating signal. Gibalid distance sa duha ka wave nga nag-oscillate. Pag miingon sa tag-oscillate, other term niya is swing back and forth. Just try to imagine a jumping rope. So, in a series LRC circuit, the phase angle represents the difference in phase between the applied voltage and the current. It is crucial concepts in understanding how the circuit's components, your resistor, inductor, and capacitor interact with alternating current or your AC, and how they affect the overall impedance. So, ang phase angle kay isa siya sa importante nga concept o giunsa sa mga parts o components sa circuit such as your resistor, inductor, and capacitor nga mag-interact sa alternating current or your AC ug kung giunsa pod pag-effect niya sa overall impedance. So, since na-mention naman ni Miss Rowena what is impedance, but let me tell you again kung unsa ang impedance. So, kung moingon mangguddag impedance, mo na siya ang combination sa reactance and resistance. So, it determined by the interplay of the resistance, your R, your inductive reactance as your XL, and the capacitive reactance as your XC, within the circuit. Overall, phase angle is very important concept in electrical circuits because it helps us understand the interaction of current and voltage. So, by studying phase angle, we can better comprehend complex electrical system. It means kung makabalo gid ta kung unsa gyud ang phase angle, makabalo na dayon ta kung unsa gid kalisod ang pamaagi sa kuryente.
Now that you've already know what is phase angle, let me introduce to you the formula. So phase angle can be calculated using this formula. Phase angle is equals arctan times XL minus XC over R.
But before going deeper about this formula, which is your phase angle formula, let me discuss kung asa gid gikan ang phase angle nga formula. So going back sa gi-discuss ni Rowena nga formula which is ang voltage amplitude. So let me rewind you again kung unsa ang naa sa voltage amplitude. So voltage amplitude formula has tan phase angle is equals VL minus VC over VR, which your VR is equivalent to your current times resistor, and then your VL is equals to your current times angular frequency times inductor or your inductive voltage. Now, your VC naman is your 1 over angular frequency times capacitor or your capacitive voltage. Okay, now, let us derive the formula of voltage amplitude to get the phase angle formula. So, tan phase angle is equals VL minus VC over VR ang imong ibutang. Ang equivalent na lang ani ang imong ibutang, which is your current XL minus XC over IR. Okay, so gihatag naman ang equivalent, which is kana. So imo na pud siyang isulat kay mag-derive na gid ta. So I XL minus XC over IR. After dayon ani is mag-cancel na dayon ta sa current since wala man si current sa phase angle nga formula. So cancel, cancel. After that, makuha na din nato ang phase angle nga formula, which is your phase angle is equals arctan XL minus XC over R. So now, this is your final formula for phase angle. Okay, so after discussing the formula of phase angle, let me discuss this diagram. So the diagram shows graphs of current and voltage versus time in an AC circuit. So the current waveform is represented by a cosine function as indicated by instantaneous current is equals maximum current cos angular frequency multiplied by time. So the voltage across a resistor is also a cosine function given by instantaneous voltage is equals maximum current resistor cos angular frequency multiplied by time. So the current and voltage waveforms are in phase, meaning their peaks and troughs occur at the same time. This is characteristics of resistive circuits where the voltage across the resistor is directly proportional to the current. So the amplitudes of the current and the voltage are related by Ohm's law. Your V is equals IR. So this means the maximum voltage is equal to the product of the maximum current and the resistance. So overall, a purely resistive AC circuit, the current and voltage are synchronized, leading the efficient power transfer. Okay, after discussing the graphs of current and voltage versus time, let me show you their individual formula. So for the current in terms of their maximum, the formula is instantaneous I is equals maximum current cos angular frequency times time, where your I is equals instantaneous current. And your big letter I is your maximum value or peak current. Now your W is your angular frequency. And for your T represents the time. Source voltage formula is instantaneous voltage is equals maximum voltage cos angular frequency times time plus your phase angle, where your small letter V is your instantaneous voltage at a specific time. And your big letter V is your maximum voltage or your peak voltage. Your W is your angular frequency. And your T is your time. And your pi is your phase angle.
So now let's have a problem in which in a series circuit above, suppose R is equals 300 ohms and L is 60 millihenry and the C is the zero point 0.5 microfarad and the V is equals 50 voltage and the W is the 10,000 rad per seconds. So, letter A, find the resistance of XL and XC. Then letter B, find the impedance and find the current amplitude, the phase angle, and the voltage amplitude across each circuit element. So, let's solve this problem. First, we will find the inductive reactance in which XL is equals WL or 2 pi FL. W is equals 10,000 rad per seconds. And the L is equal to 60 millihenry or the value of This is times 10 to the negative 3 H and equals to 600 ohms. So this is our inductive reactance. Next, let's find the capacitive reactance in which Xc is equals 1 over Wc or 1 over 2 pi Fc. 1 over, since the value of W is 10,000 rad per second, and the C is 0.50 times 10 to the negative 6 kay microman siya. So, and equals to 200 ohms. So this is our capacitive reactance. Next, let's find the impedance in which Z is equals the square root of R squared plus XL minus XC squared. R is equals 300 ohms. So, squared plus the katotong gisolve kaganihan nga XL of XC which is 600 ohms minus 200 ohms squared. And the answer is 500 ohms since the unit of impedance is ohms. Next is the current amplitude where I is equals V over Z which 50 over 500. So the answer is 0.10 amperes. So this is our current amplitude. And next is to find the phase angle in which phi is equals arctan XL minus XC over R. So arctan times the value of XL. So ato na siyang i-minus daan which is 600 minus 200 is 400 ohms and the resistance is 300 ohms. So the answer is 53 degrees. And the last one is to find the voltage amplitude across the components. Where first we are going to find the VR. VR is equals IR. So current which is 0.10 amps and the resistance of 300 ohms. So the answer is 30 volts. And next is the voltage inductance where VL is equals IXL. So I again 0.10 amps and the value of XL is 600 ohms. So the answer is 60 volts. And the last one is the voltage capacitance in which VC is equals IXC. So again na po, ang value sa I is 0.10 amps and the XC is 200 ohms. So the answer is 20 voltage.
So I have here an example problem. So assumes that the current is maximum at T is equal 0. The current and the voltage all oscillate with the same angular frequency of 10,000 rods per seconds and hence with the same period of 2 pi per angular or your 2 pi
10,000 rods per second. The current is 0.10 amps and the voltage amplitude of VR is 30 volts and the VL is equals 60 volts and your VC is equals 20 volts and your phase angle is 53 degree. Find the expression for the time dependence of the instantaneous current and the instantaneous voltage V, the resistor, inductor, and capacitor, and your AC circuit. First, we're going to find the instantaneous current. So for your formula of your instantaneous current is your instantaneous current is equals maximum current cos angular frequency 10 amps cos 10,000 rod per seconds times time is equal 0.017. So now, let us find the instantaneous voltage. So the resistor voltage is in phase with the current. Remember, your resistor voltage is in phase. So we must use this formula. Thirty volts cos 10,000 rods times time is equals to 5.21 voltage. Okay, so now let's find your inductor. The inductor voltage leads the current by 90 degree. Remember, your inductor is lead. It means it is positive. The formula you're going to use is this. Negative 60 volts sine 10,000 rad per seconds times time is equals 59.09 voltage. So now, let us find your capacitor voltage. The capacitor voltage lags the current by 90 degree. Lags. Remember, your capacitor voltage is lag. So, the formula we're going to use is this. So, 20 volts sine 10,000 rod per seconds times time is equal negative 19.69
or 20 volts. Now, let's find your source voltage. So, for your source voltage, you're going to use this formula. So, 50 volts cause 10,000 rad per second times time plus 2 pi rad over 360 degree. Or 50 volts cause 10,000 rad per seconds times time plus 0.93 rad. Is equal to 9.48 voltage. And if you are wondering kung asa gikuha ang 0.93 rad, maora na ang same ra na siya og answer sa 2 pi rad over 360 degree times 50 degree, which is ang answer ana is 0.93.